For this video I'm going to talk about an idea, something that will not be specific to Boxer at all. It's a idea, a quality that I've noticed in many systems that I love. But Boxer gave it a name, Detuning. And even if that name didn't catch on, I've never seen anybody else use that name. I haven't seen other names for it, and I still think it's an important idea. And we'll also talk about the implementation strategy of multiple representations for semantically the same thing that goes nicely hand in hand with it, and we'll see how it happens in several languages. So let's talk about dynamic languages like Python, JavaScript, Ruby. If you've coded in these languages, you probably noticed that you are 99% of the time you're using just a couple of collection data types, hashes, arrays, lists, dictionaries, whatever you call them, and it's enough for practically any purpose. That kind of flies in the face of the computer science data structures course. Shouldn't you be doing import collections.dequeue for a specific place where you need a double-ended queue to optimize insertions and deletions on both sides? Or shouldn't you be using a balanced binary search tree for exactly those situations where you will need to access the data in sorted order more than once? Object-oriented programming might also look at code full of these kinds of the same data structure all over and say, that's not good, that's a primitive obsession, that's an anti-pattern. But if you've coded that way, you probably felt that there is more to it. You're not just being a lazy programmer. There are benefits to working in this style with a few structures. And this is not a new idea. If we go to other people have talked about it, for example, Alan Perl in his famous epigrams has a frequently quoted sentence that epigrams that it's better to have 100 functions operate on one data structure than 10 functions on 10 data structures. So why is that? Obviously, it's one benefit it gives you is composability. If you have if all of the functions takes only a few types return only a few types, it's much easier to combine them one with another in ways that were not foreseen ahead of time. This is also why Unix pipes work so nicely. Because the interface is all forced to be the same text. It's used in various styles to represent different things. You can have files with nested structure like XML, or indented structure like Python code, or tables, but you can pass all of them through grep. Even if it's wrong thing to treat it conceptually wrong to treat your, say, XML pipe as a series of lines. It's not, it's a nested tree, but and there is no, if you don't know how it was constructed, there is no guarantee how many lines it will be. It could be one huge tree on one line or whatever. But in practice, frequently you can get, at least in interactive use, when you know where the data came from and you know how it's structured, you can do all kinds of combinations that are not foreseen, and that's a nice benefit. Another benefit is other benefits are more of the cognitive kind. It's easier when you don't have to think all the time about making a choice out of like 20 options. If you have just 2 options and you have more operations that work on these options, remember the 100 functions on one data structure, then you can then it's much easier to make a choice. In extreme cases like Lisp, you don't make much of a choice. You have only one, at least early Lisps, you have only one collection lists, and that's what you do for everything. But Lisp is not exactly an example of what I want to talk about, because it will not be an example of cannot be an example of multiple representations, because when Lisp programmers use a list of pairs to represent the mapping, there is no way to make that efficient, because Lisp exposes too much of the linked list nature of these lists directly. There is no abstraction there. There are benefits to that style as well, but that's not the exact area of design that I want to talk about in this video. So there are cognitive benefits. There is less verbosity. Right? When reading the code, you don't need to focus on all the long names. You can have just a few characters denoting the collection type you have, because you only have a few of them in the language. So let's talk about a few languages which made this kind of... Okay, wait. Before we go into the languages, let's read what Boxer designers had to say about this idea. Go back here. Detuning means having general structures underlying the computational environment that are broadly applicable, less highly tuned to any specific functions, and always available for use. I particularly love the explicit admission that they're less highly tuned for something, as and the name detuning as it focuses on the fact that this is not necessarily a drawback. This can be a positive thing. It's a trade-off. In Boxer, this means such thing as the existence of exactly one kind of data object. We'll see some other languages in this video where there is one collection. There will be no essential difference visible to the user between strings, numbers, lists, records, and so forth, except the way in which the data object is used. Even variables and files will be essentially the same structure. So Boxer carries this idea to not only to programming language design, but also it applies it to UI design, because in Boxer the whole environment is intended to be a thing you live in for a significant time and do a lot of work in that environment. So it tries to encompass both things that are programming level things like variables, and things that are normally nowadays you treat them as desktop level concepts, operating system concepts like files, directories. And Boxer there's the same structure for the whole gamut, from variables to directories. But in this video, now let's forget about Boxer. In this video, let's focus on other more familiar languages, and which are just languages and have less aspirations of becoming your whole world. So first, let's talk about switch to the board. Let's talk about Perl. Perl is kind of, I'm choosing Perl because it's kind of a poster child for unification between strings and numbers. Perl just have a single name for them, a scalar, and it doesn't distinguish them, and there are some prices to pay for this particular mixing of strings and numbers is quite common in many languages. But Perl went pretty far in following the consequences of this decision. So Perl has different operators. How do you know if something is string is a number if it doesn't remember whether it's string or a number? At least not in the language semantics. We'll talk in a few minutes about the internal representations. But officially, it's just the same. So how do you then know if you're saying 3 plus 12? Is it addition or string concatenation? So Perl has different operators. This is numeric addition and returns 15. It coerces them to numbers whether they were numbers or not. And if you do the string concatenation operator, I don't remember, maybe I need parentheses around them to not parse as a floating point number, even with spaces. Anyway, you get a 3, 1, 2 string, right? So and similarly, you have distinct operators for comparison. You have if you do I don't remember exact direction now. Man Perl would tell us, but anyway, you can do comparison of with a sign or with less than letters. These are distinct operators. One of them has lexicographic comparison, one of them is numeric comparison. I don't remember which one is which exactly. So, but internally, are these actually always represented as string? If you do a lot of numeric computations, would Perl force you to convert them to strings, decimal and back all the time? No, internally it has, it can represent them as numbers, it can represent them as strings. I'm less familiar with the Perl internals, but it has at least these two. I'm not sure if it has divisions between integers and floating point, etc. in the representation or not. But that's the idea. And we'll see more about the multiple representations in another tool very soon when we get to Lua and Tcl. I just don't know enough about the Perl internals to talk more about this. Now let's go back in time to awk. Awk is, at least of the languages I'm familiar with, awk was perhaps the first, at least in the Unix world, it was very influential in popularizing hash tables, it called it associative arrays and cited Snowball as an influence. So Perl also has a mixture between numbers and strings, but that's not a full. In awk, actually, I looked up the awk book and okay. So first, let's talk about arrays. I'll mention the string numbers not being exactly this idea later. But for arrays, awk has just one collection type. And you can index it by numbers, you can index it by strings. I think you will also even get the same thing if you access it by numbers and strings, because it should not differentiate them to this degree. I'm not saying. But the point is, you can index it by numbers and you can index it by totally non-numeric strings. Yes. So internally it's a hash table. They call it an array or an associative array if you press them for details, but it is a hash table, and you can use it with numeric indexes to have an array to work it with a sequence, but the indexes don't need to be consecutive, and they don't even need to be numeric. They can be any string. And it's just one collection, playing both parts, both for the array use case and the hash use case. And at that stage in history, they didn't bother to optimize them much. These are always hash tables. And it was, I think, important benefit of this design for their use case of brief programs, frequently only a few lines, that you might even write interactively at the command line in the middle of a shell pipeline, that you don't need to bother with type declarations. I think they mentioned it somewhere in the book that they didn't want to have any type declarations. That you don't need to bother with deciding whether... So similarly, you don't need to bother with declaring whether it will be an array or a list or a hash, whether declaring how to initialize variables, everything has null, empty, zero kind of default values. So brevity that is somewhat enabled by having only one data structure was important here. And now to go back onto the question of are strings and numbers semantically equivalent in awk? So not exactly. I found on page 192 of the book, but it's not loading now maybe. Anyway, they have admissions that it's the language, as far as I understood it, the language does remember semantically whether it's a number or a string, and there is slight differences in behavior. They say that mostly, as a user, you mostly can ignore it and pretend it's just one data type, but actually it's two types slightly similar. In contexts where types cannot be reliably determined, the type of each field is determined on input. All fields are strings. In addition, each field that contains only a number is also considered numeric. This, by the way, is interesting. We'll see it again soon. Something can be both a number and a string as far as the language is concerned. All values are strings, and some of them have numeric meaning. And again, I'm not sure about the internal representations of strings versus numbers here. Do they bother with internal binary representation or floating point representations? Or do they just store them as string? But semantically, it seems that they're approximately think these ideas of just the same thing, but it's different. So what I wanted to focus on for awk was mainly the idea of having one data structure for both the array and hash use cases, and using hash as a. By the way, JavaScript is different. It has two different types. There are objects and there are arrays, but you will notice that the arrays in JavaScript are don't have to have consecutive indices. It's easy to write to a later index and skip over a whole bunch of indexes, and the intermediate ones will become, I don't remember, undefined, I guess. Anyway, let's advance to Lua. So we mentioned Perl, we mentioned awk. Now we are at Lua. Lua, similarly to awk, had one collection. They call it a table. And again, a table can contain numbers, it can contain strings. I'm not going to talk about numbers versus strings, I'm not sure about that. I'm more interested in, actually, kind of, the whole numbers versus strings was kind of a digression. It's a similar theme, but I'm more interested here about the collections, where you can put other things. So Lua tables were initially naively just hash tables and storing the numeric indexes if you use them as array. Okay, I'm not sure if it had literal syntax for arrays. Actually, it didn't have much functionality for the array use case. It was mostly focused on the hash use case. Could it print an array in sequential order easily? Could you write a literal for array as an array, thinking about it as a sequential array? I don't remember. In Lua, you have both syntaxes, but underneath, I think here was syntaxes. Underneath, it's a table. It's semantically, you get the same data structure, data type, and you can use it in more like array style and more like hash style. So Lua 5.0 is an interesting point. The Lua 5.0 design paper, it says that originally they were strictly hash tables, and they kind of invented, they might have been the first for specifically this combination of hash and array in one place, the idea of hybrid storage with two parts. Each table has a possibly empty hash part and a possibly empty array part, and they have an algorithm for dynamically optimizing the division between the array and the hash parts. The array part is beneficial because indexing is random access without going through the hashing function, and indexing it's more efficient for memory because you don't have to store the keys. If your keys are just sequential integers, you can say omit them in this part. and have some clever optimizations trying to figure out how large this part should be in the presence of non-consecutive but still pretty dense indexes. It's probably a rare use case, right? Most of the time, if you are using it as an array, you will only have consecutive indexes and that's it. So yes, they list the best benefits. First, it's faster, and array part takes roughly half the memory. And they talk explicitly about the two use cases being somewhat, despite having the same interface, the same API for just one structure, the usage styles are somewhat don't overlap much. No memory or time penalty is paid for the hash part because it doesn't even exist if it is being used as an array. Converse holds if the table is being used as an associative array and not as an sequential array, then the array part is likely to be empty because you will only have strings that don't even look like numbers. This is the idea of multiple representations. So on one side you can design one type, one API to cover multiple use cases. On the other hand, under the hood, you can have multiple representations that dynamically optimize for how you are using it. Okay, so now let's proceed to Tcl. And with Tcl, we are going to play with Tcl has a similar story of initially having a naive implementation, and Tcl 8.0 did a lot of optimizations and with multiple representations. So I think, okay, I'm gonna show this mostly in the terminal. So I'm opening a Tcl shell. Tcl is a string, entirely stringly typed language. There are only strings, semantically. It is somewhat similar to Unix shells, but has much cleaner semantics, especially much cleaner quoting semantics, which makes it pretty easy to do nested structures, unlike Unix shells. We'll see that in a moment. Let's start with a number. If we define a variable set n42, there is the reason it's going to be fun to play with Tcl now is because there is Tcl unsupported representation command, and you're not supposed to pick at it, but it's handy for our kind of debugging and for debugging of performance. But the things it tells you are things that have no semantic meaning in the language. If we look at the browser, go to the Tcl wiki, they're quoting any Tcl object is not isomorphic to a string is a bug. They're doing optimizations, but they very much want you to feel still that semantically everything behaves as if it was a string. If it deviates from that, if you can detect the difference, except using the unsupported peek under the hood debug command, then it's a bug. So what does it tell you? Value that I gave it, like it's a pure string. Looking at the structure of this statement, it's obvious that it's going to be a string because it looks like a shell command, right? I'm doing string interpolation here, inserting the value of n as a string, and then it's gonna be split on words and parsed as a command. This is a command, this is the first argument. It's all right. Obviously, it's going to be all strings. That's the semantics. But what's going on here is still consistent. This is a pure string with a reference count of 4. Reference counts with this internal call are confusing because there are some temporary references that exist at the moment of evaluation of this command that are gone by the time it's printed on the terminal. Currently, it probably has a reference of 1 or something like that. Anyway, and it has string representation 42. Okay, Now let's compute $n+1. It worked. And now let's repeat our question. How is it represented internally? Value is an integer with a ref count of 4. Object pointer still the same. Internal representation, this is probably hexa 442. Yeah, 32 plus 16 plus 10. It's 42. And string representation 42. So now it has two representations at the same time. This is a great time to show this wonderful quote. TCL objects are like storks. They have two legs, the internal representation and the string representation. They can stand on either leg or both. This is beautiful. It's attributed to Donald Fellows. So let's go back to the terminal. Here it's standing on two legs. It has both a numeric and a string representation. So now let's do data structures. Set we'll have something that looks like kind of an array, but let's have foo is value of 12 and bar. So no, okay. So okay, let's do something nested. So let's check the representation. Sorry, not $n, $a. So this thing is again a pure string because I initialized it from string. It doesn't have any idea about what I'm gonna do with it. And here is the string representation. Foo space 12 space bar space brace, etc. But now let me try accessing it in some other way. So there is list command with some options like list index. Let me grab, the indexing is 0 based, so list index 3 will refer to the last puts hello thing. I think I need to do it like this. I'm sorry, I'm gonna pick L index. Yeah, list command constructs a new list. Yep, L index 3. Okay, so we have our puts hello. Now let's pick again at the representation of that same $a. Something funny happened here. It was a pure string. The object pointer is still it's still the same object at memory. And now it has some kind of internal representation. It's again a pointer, doesn't tell us much. And a string representation. And it is a list. Let's do more than that. Let's put the inner part in another variable. Now, semantically what I'm doing here is undergoing several stages of kind of string expansion like in shells. I did a string interpolation here of the value of $a, which is this whole thing, and it was braces in TCL are a genius thing. Braces are quotes, but they count internal braces that are not escaped, they skip over them. So the string that starts here ends here. The use of double asymmetric delimiters for mirroring, but not the same delimiter for the start and the end of the string, allows nesting strings one inside the other without all kinds of backslash hell. And it's brilliant. And I wish many more languages would pick this up. Especially languages focused on strings like command line shells. Anyway, here we did sort of a string interpolation. Now the result of this command, we interpolated it into the outer command. So now we have set inner and with that same string. But internally the language, the interpreter knows where it came from. It knows that this is the result of executing this indexing command into this string, which is no longer just a string but also has a list representation internally. It has been already chunked into its 4 parts. So now let's see, let's look at inner. Sorry. Inner is this thing, which happens to look like a command you can execute. I did it deliberately. So let's see. So let's look again. The string representation of the outer array is still the outer string thingy. The outer thingy is still represented as a list with both a list representation and a string representation. And the inner, the inner representation of the inner part is a pure string with this content. Now let me do let's start with a simple thing. Let me do an L index on this. Inner at place 0, so get the puts, and I can get the hello part. And now I can see that the representation of this inner thingy is also a list with 2 elements, puts and hello, and the string representation. This is a stork that stands again on 2 legs, a list leg and a string leg. Now I'm gonna try something. So if you look at our let me try to write it here. We have this to draw it. Right, we have this thing. So we have the variable inner pointing here, and we have the variable a pointing here. And I'm going to demonstrate you to use it implementation-wise. This shares storage now, because the external variable has been chunked into parts and stores them as separate elements under the hood. And the internal representation points at exactly that storage. I'm going to access it again. I'm going to do, I'm going to try an eval on what I'm going to get from the L index $A3. So I'm accessing the internal, these are my indexes, right? So I'm accessing this part, but I'm going from the $A at place 3. And we'll see that this shares a pointer with what we already captured in $inner. Yeah, type L index. Hello. It was executed. The text contained inside is puts hello. This is one of the nice side effects of TCL design with nested strings being easy to write, is that the control structures are just things that manipulate strings to execute. If statement, etc. are just regular commands that take a string to execute. They are not. They happen to look like C blocks, but they are just quoted strings. So let's pick at the internal representation here through the inner pointer. So I'm now coming from here, and I'm saying it used to be, it used to be a list with some kind of array representation and then a string representation. Now it's a bytecode object. It still has the same string representation. String representation cannot change. If I understand correctly, TCL objects, which stand for strings, so semantically TCL strings are all immutable. Strings that you used in some command cannot possibly change in place. You can only get new strings produced from it. You can change variables to point to new strings, but the existing strings are immutable, I think. So it still has the same internal representation has a different pointer, yes, but the object is the same object, and the string representation is obviously the same, but now it's a bytecode object. But see what we did? We went from the $A, we descended that structure to say, tell me your third argument. We it looked like we are doing a string interpolation. We are generating the string L index $A and 3, and we are then passing it to interpolating the output of that into the eval command. But actually, this was all compiled into code that is passing pointers around. And still, this is undetectable to users. This sharing is just internal, but we access it from here, and we change the representation that we can observe from here. So it's pointing to a string, but under the hood, the string has an optimized representation. We can also do dictionary access. Let me look at the dict command. N section of man pages is a Tcl specific in docs. Dict append, dict get. Okay, let's try dict get $A at place bar. Now it's no longer let's see. Don't believe me. Let's look under the hood. Now the external structure changed. It is now a dictionary with 2 entries. Dict keys $A will tell us in keys are foo and bar. So now it's a thing like this. It also remembers the order of elements because it must, because to behave like a string it must retain all the titles. And now if we try to let's see, if you try to access, I'm accessing from $A, which is now a dictionary internally, to again access this last part. And I'm curious if it will change if it's still sharing the pointer with the inner variable that points directly to that part. So when converting between dict and string, did it reuse the same chunking into elements, or did it do it again and disentangle the structures? No, sorry, not this one. I wanted to now check is inner pointing there. So no. Let's do it like this. When accessing it from outside, from the dictionary, I'm accessing a list. When looking at the inner variable, I'm looking at a string. I also probably detect that I got a new object pointer, and probably before I didn't think before to probe it, but I could also probably before see that when they shared the same pointer, that the address was probably the same. Anyway, so one more thing I'll mention. As you can see, the same structure can stand at more than 2 legs, right? So if always one of them is always a string, is reserved for string representation. So it can be a dictionary or a list or something else, or a bytecode, only one type at a time as far as the internal representation goes. So if you mix a lot of code that sometimes access it as a list, sometimes access it as a dictionary, you might get bad performance because it is going to do internal conversions back and forth. You probably don't want to write such code. I don't remember if Tcl supports multithreading. In languages that support multithreading, doing this kind of optimization under the hood might be a risky idea, because if you have 2 threads running in parallel accessing the same structure, and they're going to cause this structure to flip between 2 representations all the time back and forth, that's not good. Tcl people have a name for this kind of bad performance due to flipping between several representations called shimmering. It's a nice name. It's not really this semantics wise the language is still, the program is still correct, everything is behaving. It's like kind of non-physical issue in that world that the performance will be bad due to invisible changes that are going on in the internal representation. And one more thing I didn't demonstrate is the whole one leg or the other. So for that we need to let's create a D variable with now create a dict, directly dict create creative here. Dict keys $D, it has just one key, and now if I pick at the internal representation of $D, you will interesting. The set command already returned the result of dict create as a string, so that, and it got printed, and as a result of that how can I? Okay, yeah. Let's pass the result to some other command, like dict keys, that will inspect it, but will not have to convert the whole thing to a string. So I hope that the string representation would not even get constructed. So let's call this dict constructor again. So you don't really need the dict constructor. Yes, you can write key value. It's easy enough to spell out this stuff. Sometimes you want it because you want all the elements to be dynamic. Also, you could do key whatever that computes a value, and you could compute the key dynamically. Yes, Tcl syntax makes it easy enough. I'm not sure about the syntax here. I think if I put it inside braces, I can no longer, the internal square brackets will not be evaluated at the same time. I can probably do something like this. Anyway, what I'm trying to say is that because dicts and lists are just a convention of how to interpret and how to structure strings for a specific use case, you don't really need these constructors. But they do have, sometimes they're convenient, and they do have a benefit of being efficient after the Tcl 8.0 optimizations. So let's see. No, that's not what I wanted. I wanted to pass it to another function. But I also want to store it in a variable for later interrogation. So let's see if this will work. Now let's look at the $D2 variable. That didn't work. However, let's try something simpler. Will this work? No, it's... So I'm not sure if I can at all create a dictionary which doesn't have a string representation initialized, but I think I saw it in some other cases. Let me try this. Oh, nice. So just dict was a bad choice for that kind of thing. But here we see a list. It has an internal representation and no string representation. So let's see if I was overly set L bar. Now it did print it out, but did it have to construct the string representation? Yes. Now if I try the more let's see what kind of operations we have on lists. Okay, yeah. So let's try. There's probably a command to just ignore a value, but anyway. Yep, so I was able to put a variable inside initialize a variable to a list, and by not having to print its full text to the console, I avoided creating the string representation at all. Okay, so I think that's it. Here is your stork. It can stand on one leg or the other or both. This is the idea of detuning is the idea of using one structure for multiple purposes, and accepting embracing the fact that it might not be as suitable for each of these use cases. For example, with the number string duality, we kind of feel it. With collections, it's cleaner. With number and strings, there are aspects like sort order that just don't jive well together. Or in Perl, you can see that the string that consists only of the digit 0 is falsy. 0 will be truthy. It will have because it's not how. If you force it to be a number, it will be converted to 0, but it still remembers when you create this string, it remembers the exact string representation 0, 0, yes. This is getting confusing, but the point is that there are all kinds of artifacts from mixing strings and numbers that have drawbacks. You don't have to do it in your language unless you are by design very intentionally focused on strings, but if you but for collections of all kinds, you can do these kinds of things, and you can even mix between strings and collections like Tcl. So in this video I'm not going into what Boxer does, I'll keep it to the next video, but it does have string representations and chunked representations created by the chunker at the same time. So that's it for this video. See you in the next one.